Welcome to this screencast where we'll illustrate the idea of writing a proof plan. When you do a coordinate proof, you might be tempted to calculate everything you can think of, regardless of whether each calculation is actually needed for that specific proof. There are two problems with this approach. First, by doing more calculations than are needed, you increase your chance of making a mistake. And since your final conclusion will be based on those calculations, the mistake will lead you to a wrong conclusion. Secondly, since the purpose of a proof is also to convince someone else of your conclusion, having extra calculations might actually distract them from following your train of thought. So now let's discuss what a proof plan is. It's just a worded explanation of the specific steps you will take to complete a proof. Writing a proof plan will help you stay on track and will make your proof easier to follow for someone else. How do we decide what steps belong in our proof plan? Well, let's revisit a problem that we have done in an earlier screencast. Let's say you were asked to write a proof that classified the triangle you see on the left. On the left, you see that I've included an illustration of how we classify triangles. Notice, to determine if we have an isosceles or a scalene or an equilateral, it's all about the sides and whether you have no sides equal, two sides equal, or three sides equal. Once we know what type of those three we have, we want to look and see if there might be a right angle. Notice there's no thing coming off the equilateral because there is no chance for a right angle with an equilateral triangle. So if we have one with an isosceles triangle, it has to be right between the two congruent sides. And if it's a scalene triangle, the right angle would have to be opposite the longest side. The words you see in red below is actually my version of a proof plan. It outlines the steps that I would take to carry out the proof, and I write it right into the beginning of my proof. Notice, the first thing I mention is that I'm going to use the distance formula 3 times. That's because the thing that I need to know first to make my first classification is how long the sides are compared to each other. If you were actually asked to do the proof, after writing a paragraph similar to the one that I have in red, you would then carry out your steps and finish with a worded conclusion. This screencast, however, is only focusing on how to form our plan. Now let's consider what steps we might want to include in a proof plan for classifying quadrilaterals. This diagram was taken from your online text and it shows the relationships between various quadrilaterals. You can see the definitions are inside the parentheses below each figure. Notice the first piece of information that may be helpful is whether or not we have parallel sides. Whether we have a trapezoid or a parallelogram, we need to know how many pairs of opposite sides are parallel. This is where slope can be really useful. Do you remember that when two lines are parallel, that they have the same slope? Both of them would be A over B. And do you remember that when two lines are perpendicular, there's a right angle there, then they have negative reciprocal slopes? Well, when we're being asked about parallel sides, we can use slope in order to figure this. So basically, unlike triangles where finding the lengths first is most effective, it is most helpful with quadrilaterals to go about finding the slopes of all the sides first. When you calculate all 4 slopes, notice if no sides have the same slope, that means you just have an ordinary quadrilateral that can't be more specifically classified. However, if you have one pair only of parallel sides that are showing up, that means it has to be a trapezoid. Now, if you have a trapezoid, you might want to know if it might be more specifically a right trapezoid. So you'd need to know if there are right angles. Well, very conveniently, since you've already calculated the slopes, you can just see if they happen to be negative reciprocals. And if so, then you know that there's a right angle where those two sides join. If there were no right angles, it could possibly be an isosceles trapezoid, so now you'd need to go use a distance formula to see if the non-parallel sides have the same length. If both pairs of opposite sides are parallel, then that means you have a parallelogram, which could more specifically be a rhombus or a rectangle, or the most specific, a square. So if we have a parallelogram for sure, now we need to see if it's a rhombus. To see if it's a rhombus, we would need to use the distance formula at this stage to see if all sides are equal. If it were a rectangle, that should be obvious just from looking at the slopes again, because you'd have to have 4 right angles, so every adjacent side would need to have a negative reciprocal slope. Finally, if all the neighboring sides had negative reciprocal slopes at each corner, and if all the side lengths using the distance formula were all the same, you would know you have a square. If asked to classify a quadrilateral, then the word you see in red would be an example of my proof plan, which I would include at the beginning of my proof. So to summarize this screencast, if I'm classifying a triangle, I will calculate lengths first, since that gives me the information I need to begin sorting through the different types of triangles. If I'm classifying a quadrilateral, I will calculate slopes first, because that tells me the necessary information to help me begin the sorting process. One last note, whether you are asked to prove what type of triangle or quadrilateral you have, or whether you're asked to prove something else, always form a plan first and include it at the start of your proof. For some proofs, you may need to calculate midpoints. Resist the urge to calculate all slopes, lengths, and midpoints for all the sides of a figure. Take a moment to think about what information you actually need, and then form a plan that will accomplish that. Please feel free to pause the screencast if you need more time to read the summary. Otherwise, I hope that this screencast was helpful.